Hi everyone. In this video, I am going to discuss problems on EMF equation. First problem, if the maximum flux density in the core of 5 kVA, 4.4 kilovolts by 400 volts, 50 Hz single phase transformer is 1.2 Tesla and the EMF for turn is 10 volts, determine first A bit the turns in each winding, B bit the current in each winding at full load condition, and C bit the cross sectional area of the core. Yeah, is it clear? The first, understand the question. The maximum flux density of 5 kVA means this is the rating of the transformer. 5 kVA means rating of the transformer, and voltage ratio is given 4.4 kilovolts means 4400 volts by 440 volts. This is the voltage ratio. From this voltage ratio, it is clear that it is step down transformer, and supply frequency is 50 hertz, and single phase transformer it is, and it is having 1.2 Tesla. Maximum flux density is 1.2. Okay. And the EMF for turn is 10 volts. EMF for turn is 10 volts. Yeah. First write the given data as it is. Given data. Given data. First giving rating of the transformer. Rating. Rating denoting by letter S. It is equal to 5 kVA, that is equal to 5000 volt amperes, because transformer rating is in volt amperes. Then voltage ratio, that is V1 by V2 is equal to 4.4 kilovolts by 440 volts, that is equal to 4400 volts by 440 volts. V1 by V2 is equal to 4400 by 440 volts. Next, frequency F is equal to 50 hertz. A single phase transformer, the maximum flux density. Maximum flux density. Flux density B is equal to 1.2 Tesla, or Webers per meter square units. Remember, Webers per meter square. Otherwise, right? Maximum flux density B is equal to 1.2 Tesla, or Webers per meter square. Okay. And EMF for turn. This is the main important thing you need to understand from the question. EMF for turn means V1 by N1 or V2 by N2 is given 10 volts. EMF for turn. EMF for turn, that is V1 by N1 is equal to 10 volts, or V2 by N2 is equal to 10 volts. Okay. And this is the data given from the question. Next, we need to calculate the turns in each one. Means we need to calculate in one number of turns and in two number of turns. A bit. Number of turns in primary and secondary. primary and secondary. The number of turns in primary is nothing but N1. Therefore, from the from this relation, from this relation, I am writing first V1 by N1 is equal to 10 volts. We need to calculate N1, therefore N1 is equal to V1 by 10, and V1 is nothing but 4400 by 10. Therefore, N1 is equal to 440 number of turns available in the transformer. 440 number of turns available in the transformer. Next, I am considering EMF for turn in the secondary. Is V2 by N2 is equal to 10. From this, N2 is equal to V2 by 10. What is the value of V2? It is 440. 440 by 10. Therefore, N2 is equal to 44 tons. 44 tons available in the secondary. This is the first bit. Yeah, and from this, it is clear that N1 440 tons and N2 44 tons. Yes, N2 is less than N1. N2 is less than N1. Therefore, it is step down transformer. It is step down transformer. Step down transformer. From the voltage ratio also we are telling it is a step down transformer only because voltage in the primary winding is high compared to the voltage in the secondary winding. It is step down transformer. Next, what is the second bit? The turns in each winding. The second bit. The current in each winding at full load condition. Second bit. Current in each winding at full load condition. We need to calculate full load current. Full load primary and secondary current. Secondary current. Full load primary and secondary current. First, I1 full load means full load current in the primary. I1 full load is equal to, we need to calculate I1 full load. Yeah. And we know that from the rating of the transformer, S is equal to, we are writing S is equal to V into I. S is equal to V into I. Therefore, from this rating of the transformer, we are writing the formula for current. I is equal to S by V. I is equal to S by V. Therefore, I1 full load. I1 full load is equal to S by, we need to write V1 voltage for I to calculate I1. Therefore, S is nothing but it is 5000 and V1 is nothing but 4400. V1 is nothing but 4400. Therefore, 5000 divided by 4400. It is 1.136 amperes. I1 full load. 1.136 amperes. Next, we need to calculate I2 full load. I2 full load. We need to calculate I2 full load. Same. From this transformer, rating of the transformer only, we are writing the formula for I2 full load. That is I2 full load is equal to S by V2. Now we are considering secondary voltage to calculate secondary full load current. That is 5000 divided by what is the secondary voltage? It is 440. It is 440. Yeah. 11.52 full load is equal to 11.36 amperes. 11.36 amperes. Then, yeah, what is the last bit? Cross-sectional area of the core. Last bit, C bit, cross-sectional area of the core. Cross-sectional area of the core. Generally, cross-sectional area we are denoting with A. And to calculate cross-sectional area, there is a relation between magnetic flux density, maximum flux density, cross-sectional area, and maximum flux available in the core. The maximum flux available in the core phi m is equal to maximum flux density into area of cross section. Maximum flux density into area of cross section. And from this, we need to calculate area of cross section. Then it is equal to phi m by maximum flux density. Phi m by maximum flux density. Then we don't know the value of phi m. We don't know the value of phi m maximum flux. By using transformer induced EMF equation, we need to calculate the value of phi m. Therefore, V1 is equal to 4.44 F N1 and phi m. Here we are considering V1 voltage. Therefore, you need to consider number of turns in the primary. Okay. From this, phi m is equal to V1 by 4.44 F N1. Yes. Substitute the values. V1, how much V1? It is 4400. 4400 by 4.44 into 50 into N1. N1 number of turns, it is 440. It is 440. 4400 divided by 4.44 into 50 into 440. Then phi is equal to 0.5 m is equal to 0.054 Webers. This is the value of maximum flux. Then calculate area of cross section. Substitute the phi m value. It is 0.05045 divided by, and maximum flux density given in the equation, it is 1.2 by 1.2. 0.045 divided by 1.2. 0.045 by 1.2. And this 0.0375 meters square. 0.0375 meters square. Is this clear? 0.0375 meters square. Yeah, just highlight the answers. And it is very easy to understand. N1 and N2. Okay, and I1 full load, I2 full load. Then this is the value of cross sectional area. This is the value of phi m, 0.045 Webers. And area of cross section is measured in meters square. And flux density, maximum flux density is measured in Tesla or Weber per meter square. And based on the question, it is step down transformer. We need to, if you want, draw the circuit diagram. Then it is very clear. And here the voltage is 440 volts. Here the voltage is 4.4 k volts. And this is 0 volts. This is 0 volts. The number of turns here 440 and here 44 turns. This is N1, this is N2. Okay, thank you.